Now we're going to study something called function notation. It is similar to solving equations when using order of operations. Maybe there should be an S there. Function notation is often written like this. It is read aloud as f of x, or they might use different letters here, but f of x. When I gave you the math problem y equals 4x plus 8, it is the exact same thing as f of x equals 4x plus 8. Now what I would like you to do is solve for y when x is negative 2. So I will substitute negative 2 in for x. I will use order of operations to solve, so I have to do multiplication first. Negative 8 plus 8, I get 0. Now we're going to do the same math problem, but we're going to do it in function notation. So instead of saying f of x, because I have a negative 2 there, I'll say f of negative 2. That means for the x in the math problem, please put negative 2. So I'll have 4 times negative 2 plus 8, follow order of operations, and I still get 0. So what do we notice? I notice that every time I put x as negative 2 into the math problem, my y, or solution, was 0. This was my input, the x, resulting in that as my output, the y. If I use slope-intercept form that you talked about last year, or function notation, if x is negative 2, y will equal 0. So these are pretty straightforward problems. You are simply going to substitute negative 1 in for x and solve following order of operation. Substitute 4 in for x, negative 6, and then negative 3. Pause the video, solve those 4 problems. We will compare answers. Thank you for pausing the video. When f of negative 1 was used here, I got positive 7. F of 4, I got 14. F of negative 6 into that equation, I ended at negative 7. G of negative 3, don't be fooled just because I went from F's to G's, does not matter. I ended at negative 14. Now we're going to use this function 3 different times. This would be the challenge problem at the end. You'll first insert 4 and solve, then you'll go back to the original equation, put in negative 5, and then I would like you to try this one. Again, pause the video. We'll stop and compare answers. You may pause the video anytime as we're reviewing answers. Please pause the video. Thank you for pausing the video. When I put 4 in for x, I solved and got 16. When I put negative 5 in for x and solved, I got, that should be negative 11 down there. When I put all of this in, I substitute it in, distribute, and then at this point I was combining like terms. You may write it as 10 minus 3x or negative 3x plus 10. Both are great. All right, I changed x's to m's and f's to k's. We're going to substitute all of that in. This last one I will work out with you. Please pause the video and do the first 2. Pause the video, do the first 2. Okay, take a minute and compare answers with me. Hopefully this first one was pretty straightforward. The next one, notice what I did with the 6 and the x. The m term itself is squared, so this whole thing needs to be squared. So it would be 36x squared, negative 24x. These are not like terms, so I do not combine them. Okay, so for the next one, they're telling us to change the m's to a y, so I'll write that down. Wherever I saw an m, I will substitute a y. Then they put a bracket around. They want me to take that answer times negative 4, and to that add 3. We cannot combine like terms there, so that would have me distribute next. So I would get negative 4y squared minus plus 16y minus 20 plus 3. So I have two terms at the end I can combine. That is as far as we can go on that one. Working inside the brackets, change the m's to a y. They have a number written next to a bracket, means multiply, so we'll distribute. The plus 3 was not part of the bracket, so we will add 3 at the end. You will notice that these three are very, very similar. Please pause the video, solve, and we'll compare answers. Thank you for pausing. For the first one, when I substitute negative 5 into the equation, I get 4. When I substitute 3x into the equation, I ended with negative 6x minus 6. These are not like terms, so I may not combine anything. For this one, I first put y in for my x, bracket, times negative 3, I distributed. Then at the end, I have to subtract 8, so I combine like terms. The next problem just looks challenging, but it really isn't. It says, please solve f of x using negative 2, so I'll put negative 2 into that equation. Then I have g of 4, so I'm going to put 4 into this equation. When I get this answer and this answer, I'm going to add them together, and then I'll add 18. So I'll say it again, put negative 2 in here and solve. Put 4 in here and solve. Add those together, add 15. Go ahead, give it a try. We'll compare answers. I first put negative 2 into the equation, and I got negative 9. I put 4 into this equation, and I got 4. When I took the answer to the first equation, added it to the answer to the second equation, I get negative 5. Plus the 15 at the end, I end at 10.